Oh, hello, everyone. I am Sanjaksha here with my co-organizer Dharini, and we are very happy to introduce you guys to two amazing companies working in aviation. So thank you for joining us tonight in the Autonomy in Aviation. So also glad to introduce our volunteer Gianna for helping with the event. So starting with Women in Robotics, Women in Robotics is a non-profit organization founded by Andra Kay at Silicon Valley Robotics in California. And this is the Boston chapter of Women in Robotics. We are a professional network of women who are working or aspire to work in robotics. Anyone from any professional background who supports our cause is welcome to the group. We'll be sharing the sign up link in the chat. We also want to thank Zoom sponsors, Vecna Robotics, for the constant support. So let's start. So today we have partnered with GreenSight and Autonodyne to dig deeper into the technologies developed by these Boston-based companies, pushing the limits of aerial intelligence. I'm honored to introduce our panel for tonight. We have James and Latimer representing GreenSight. So James Perville is GreenSight's CEO and CTO and co-founder, is an expert engineer and technical executive who have focused on electrical powered unmanned aerial robotics for over 15 years. He has led a huge variety of innovative development efforts for enterprise and government, including DARPA, AFRL, and NASA. James founded GreenSight to focus on solving real-world problems using ubiquitous robotics technology. He holds a Bachelor of Science in Mechanical Engineering from Brown University and an MS in Electrical Engineering from Boston University. Thank you so much, James, for joining us tonight.
Thank you.
Latimer Gerald is a systems engineer at GreenSight with qualifications in both systems and software fields, as evidenced by her prior positions, ranging from golf caddy to optical technician to her extensive experience in the defense industry. She enjoys learning about new topics and tackling new challenges. Her curriculum includes an MS in data analytics and BS in computer science and an enduring passion for the classics. In her free time, Latimer's interests include traveling, building miniatures, attending rock concerts, and being terrible at golf. I don't believe that you're terrible at golf, but let's see.
It's true. I'm afraid it's true. But thank you.
We are really glad to have you here.
Thank you. I'm glad to be here.
So we have Shrutika and Erica representing Autonodyne. So Shrutika Ruhela graduated from Carnegie Mellon University in 2020 with a degree in electrical and computer engineering and public policy, and is now a systems engineer at Autonodyne. In college, Shrutika was president of Women in ECE, volunteered for Camp Kissim, and did research on the risks of IoT as a part of CMU's SciLab. In her free time, Shrutika runs the peer mentorship program for the Anaya Tipnis Foundation. And thank you so much, Shrutika, for joining us today on behalf of Autonodyne. We're really, really happy to have you here and excited to know more. And last but not the least, we have Erica Snow, senior systems engineer at Autonodyne, specializing in autonomous behavior. She graduated from Worcester Polytechnic Institute, yay, like myself and Dharini. So we are very happy to have you here. She graduated with computer science degree and robotics engineering. Again, welcome everyone, and thank you for coming for yet another virtual meeting. Hope it all ends soon and we get to meet with our members like in real life. So now, without much delay, let's get started. I would like to invite James to give us an overview about the company and what you do, like how you do it, and what are you excited about?
Sure. Here, let me, I made a few quick slides. So just an overview about GreenSight, as you said during that nice introduction. We founded the company to really attack real business problems using aerial robots across a bunch of different markets. And most of the markets we're focused on right now are agriculture and defense, which is kind of two polar opposites. But actually, we find that of technology parallels between those two. So we've made pretty good use of that kind of dual purpose focus lately. I founded the company in 2015 with Joel Pedlican, and we are Boston based, obviously, and have a staff of about 40. We've made almost 300 VTOL UAS, and we do mostly focus on VTOL aircraft, mostly multi-copters, and we've made those in-house in our facility in Boston since 2015, from everything from 100-gram kind of nano drones up to 100-kilo beasts. So all different types of aircraft. And we have a few we've made quite a bit more of. And during that time, we've actually done a whole broad breadth of work for a variety of different customers. Actually, over 75 different private companies and government agencies we've done projects for successfully. In addition to over 200 commercial agricultural subscription customers for our intelligence platform. So really broad base of different people we've done work with and worked with. So our kind of technology vision is ubiquitous, unattended, and automated aerial intelligence. And we've kind of built that platform in a way to work within current regulations, but also prepare us for kind of the next generation of autonomous UAVs. Built this full stack. I think we're kind of unique in that we built all of these pieces. So we actually designed and manufacture our own long endurance custom drone. It's a 60-minute flight endurance multi-copter that's about 2 kilos. It's a pretty small aircraft, which is somewhat industry leading flight time. And we did that specifically because for agriculture, we needed to be able to cover a lot of terrain. And really, that was a major limitation, and we were able to do better than a lot of the existing manufacturers. We build our own custom camera payload, which is multispectral payload, visual, infrared, and thermal, specifically designed for agriculture. And then we built all the software to handle these systems. We have our own image processing pipeline, uses machine learning to do some advanced classification work. We have a whole management and operations system we've built to remotely pilot these aircraft. And then we have a whole customer front end. So we have a geospatial platform that customers can receive their imagery in. And a couple of applications we use to kind of build analytics and deliver analytics to customers. And a lot of those are custom designed. And we've done over 9,500 flights with this system since about 2016 across 6 countries, and we've covered about 2 million acres. So really a lot of just operational experience, and we've learned a tremendous amount over that time. Lots of improvements. Our kind of focus since the beginning was to get out there, fly aircraft, and really start learning. And we've just made continuous improvements in our system over that time. And now we really have kind of a very smooth operational model as to how we do this. I don't want to dig into too many of these bullets, but company was founded in 2015. And one of the things we did when we started is we got a couple of contracts with Google and with the US Air Force. And that was kind of part of the funding that kind of launched us. We were able to turn that into some venture funding. We raised some venture funding from angel investors in 2016, and then with a strategic investor, the Toro Corporation, in 2017. And in 2018, we launched kind of the intelligence system we have now. So our next generation drone, rebuilt analytics, we designed everything from kind of the bare beginnings in 2015 and 2016. And we've kind of grown from there. We've amassed a large quantity of large partners, corporate and in the deal. We've been expanding ever since. And 2020 in particular was a great growth year for us. Despite the pandemic, there was a lot of kind of silver linings for the company. We got a lot of really good partnerships formalized during that year, and it was very busy. Despite everyone working from home, it was a great time to kind of focus on work and not flying all over the world traveling, which was actually nice for me personally. A nice change from the prior. We have really broad capabilities, and this is part of kind of, if you look at our system and what we've developed, probably not surprising. Robotics as a service is kind of a focus for us, really selling these systems as a service. Obviously, developing unmanned aircraft. We've built fixed wing, multi-copters, custom aircraft all the way up to just selling kind of off-the-shelf units. We do a lot of work in artificial intelligence and computer vision, usually building custom solutions to fit customer-specific problems. We recently did a project for the U.S. Army where we detected foreign object debris on runways. It was a great example of kind of what we can do to come in and build a custom algorithm. We do other types of robotics work. We've actually built some ground robots. We have a giant robotic arm in the office that we're using to grab drones out of the air. So kind of all different types of kind of diverse robotics problems. We kind of take on any problem that people are willing to toss our way. We have a really broad kind of roadmap of drone products, all based around this flight controller that we built called Ultra Blue, which is kind of at the core of all of the aircraft and systems that we've built. And it sort of evolved from what we originally developed back in 2016. And we've kind of refined that into its own product in itself and started selling autopilots. And part of this hardware and product strategy is based around regulatory changes. The US government has new rules now where there's certain rules around sourcing, primarily around not having Chinese hardware components in UAS. And that's opened up a new opportunity for us to sell our hardware to those types of customers because we're kind of uniquely able to provide hardware systems that meet all those new requirements. It's kind of an unplanned new strategy for us, but it's been working out quite well. So we are based in the seaport. We are actually kind of a couple blocks from the Harpoon Brewery and a couple blocks from Autonodyne. We have about a 9,000 square foot office with facilities that are as diverse as the work that we take on. We have a workspace for general engineering, but we have a nice lab and manufacturing space where we actually build aircraft. We have a lot of different prototyping facilities from CNC machining to composites, 3D printing, vac forming. Really kind of built up a lot of facilities to let us run and rapidly prototype stuff, which has been a strength of ours throughout our history. We have about 40 full-time employees and maybe about 35. how you count that. And we really have a very diverse staff. I mean, this has been, I guess you could say we're defocused, but I would say we're multidisciplinary. We have broad, really ambitious goals around technology that, and consequently, we've needed a really broad and ambitious staff. Throughout the company's history, we've really valued curiosity and people that have broad interests, multidisciplinary interests, and ultimately a willingness to learn new things to get the job done. I think when you're a small company, especially, it's hard to compete with larger companies. You have the FANG companies out there who are paying huge salaries and hiring top. And we've been more flexible. We hired a lot of people who initially didn't have a lot of experience, and we trained them. We hired people that had kind of diverse backgrounds, people that don't have college degrees in some cases. I think that's a strategy that we've really leveraged and has worked out well for us. Joel and I have felt since the company's founding that diverse hiring was really important, and it's been a strength for us throughout the whole company's history. And I'll mention one of the projects that Joel was actually kind of the founder of was a project called Mass Robotics Jumpstart, where we're mentoring diverse women young women who are interested in STEM. And we have 2 high school girls this year who are going to be working with us for the next few months. And we're always looking for mentors. So women in robotics who are interested in mentoring bright young women who are also interested in robotics, we'd love to hear from you.
Definitely, we'll spread the word.
Yeah, definitely. If our viewers did not already listen to this, please do contact Aiden from GreenSight, I guess, if you're interested.
You can contact Joel, and we can put his. I'll chat his name, or he can chat his own name in the stream.
Well,
it's a great program. You should maybe you could send out the brochure for it. I think people will be really interested.
Yeah, definitely. I think we have a lot of young women getting into robotics, like just starting. So I think this will be really helpful for them.
Yeah, thank you.
So thank you, James. That was really an inspiring origin story and really interesting work. I did not know so much about GreenSight before, honestly, like that I got to know today. So I'm really, really looking forward to this.
Thank you. Well, we do a lot more of work that's not on our website.
Exactly. Like I only saw on
as
like
with many
drones.
small companies.
Yeah, I mean, all this time I was thinking it was just about drones, but this is so much more than that. So I'm really glad that I could see this today.
Thank you.
So now I'll invite Shrutika to do the same. Just tell us more about Autonodyne, like what do you do there and how you do about it.
Yeah, sure. Let me share my screen as well. Okay, so hi, I'm Shrutika. I'm a systems engineer at Autonodyne. And Erica is also on this call. She's another one of our systems engineers. And I just want to acknowledge we work really closely with GreenSight. We're super lucky to work with them. So thanks, James, for that intro. So at Autonodyne, we call ourselves a software AI company. So our goal is to bring autonomy to uncrewed vehicles of all types. So it's a little different. People probably know more about drones. A common control station, our product is a common control station for unmanned systems. So you can kind of think of a control station as a really advanced remote, and a common control station as a really advanced remote that can control anything that you want it to. So a common control station for aerial vehicles with artificial intelligence is taking the really advanced remote and then controlling all different types of vehicles at the same time, with the computer doing most of the work, so the operator doesn't have to think too hard about it. So our goal at Autonodyne is to enable highly automated, autonomous, or optionally piloted vehicles. And our approach is to use a software-centric solution so that we can be hardware agnostic, as hardware agnostic as possible. So we've integrated our software with over 40 unmanned systems, including unmanned air vehicles, so like drones and planes, including some of GreenSight's drones, unmanned ground vehicles or ground rovers, unmanned underwater vehicles, which are like submarines, and unmanned surface vehicles or boats. So here's some pictures of us controlling all the different types of drones that we control. So like I said, a common control station, we can control all different types of vehicles. All the way on the right, top right, is one of GreenSight's drones, and the bottom middle picture is kind of fun. And the Boston Harbor, that's right in front of, if you're from the Boston area, the Lolitas in Fort Point. So we're controlling a submarine, a boat, a drone, and a ground rover, and those are all circled in the picture. And yeah, so that's the same picture again, multi-domain operations. These are just nodes to us, so we can stitch these nodes together to form a team. So all of these different types of vehicles can work together. So yeah, our main traction is combining human-machine interface and autonomy. So we have the interface, which is the common control station, and that's written in a Unity front end, which enables us to use touchscreens as well as AR, VR devices. And it's equally useful for human in the loop as well as human on the loop. So that means that the front end is optimized to be useful for an operator to be controlling the vehicle or just watching the autonomy do its thing. And it's built for multiple form factors and hardware platforms, which was the picture on the first slide if you saw, with the system running on all different types of devices. So like an Android phone, a tablet, a big screen computer. So yeah, so the vision is that the human and the machine can work together and shift levels of automation depending on the situation. So sometimes the vehicle is really autonomous, and sometimes it can like include human involvement. And then we have the Autonomy Engine, which is built to reduce more and more cognitive bandwidth. So that's the part where the person using our remote doesn't have to think too hard about what they're doing because it's intelligent. So depending on what vehicle we're working with, the software can reside on the vehicle or on the control station, and sometimes on both. So basically the system will operate on its own, and if the human needs to change the course of action, they can interfere. So our common control station is called the RC1000. This is our product. Again, 100% software solution. We don't need to add any software or hardware at the node if we don't want to. We routinely control 10 or more dissimilar uncrewed vehicles, like I said earlier, air, sea, and land by a single operator. We're scaling up to control over 100 vehicles now in different types, with all different types of sensors. We've demonstrated connectivity across tons of different data links and different message sets, stuff like that. Like I said earlier, we run on Windows, Android, Linux. And so I won't talk about all of these, but here in bolded black, you can see the autonomy behaviors that we already support. So for example, one of the behaviors I worked on recently was perch stare, which is in the second column. So in that example, we can command a UAV with a camera on board to just sit silently, so it's not emitting any RF, and maybe it's staring at a doorway or something. And as soon as it sees a human, it'll wake up and it'll tell the user that it saw someone, and then it'll relay that video stream to the control station. So that's an example where our software is running on board both the vehicle and the RC-1000 because the drone has to know when to wake up. But yeah, that's an example of the drone working together with the user. And then another behavior we support is drone delivery. So it uses autonomous path planning with the common control station, having knowledge of and the ability to tell drones to avoid static and dynamic obstacles such as weather, airspace, and threats. So you could imagine this to eventually include something like how far does the vehicle need to fly away from a neighborhood so that the residents don't hear too much noise when the vehicle is delivering your Uber Eats from across town or something like that. And I'm not going to go through all of this, but although most of our work right now is heavily government funded, we're really trying to bring this technology to other use cases. For example, wildfire fighting, search and rescue, environmental monitoring, disaster recovery. So just as an example, the first one on here, the idea is automatic reallocation of vehicles. So that's a good example. You can imagine a group of drones that are participating in a wildfire fighting mission, and then suddenly an Amber Alert is issued for a missing hiker wearing, say, a red sweatshirt, and we have the last known location. So our software will automatically put out a call to all the vehicles that are on the firefighting mission. And each drone can respond with like, I'm here, I have this much battery left, I have these sensors on board. And our software will automatically reassign the vehicles to search and rescue or continue the firefighting mission, depending on which ones have like a certain type of sensor or camera on board and what their priority is. So yeah, that's Autonodyne. We're based in Seaport as well in Boston. We also have a shared workspace at Mass Robotics, and we use the drone test cage at Costas Research Institute in Burlington, Massachusetts. We have a couple people on the West Coast as well. And currently our team is around 35 engineers. We have software, algorithms, systems, and robotics people. We've doubled our headcount every year since we started, and COVID froze our headcount. So we are recruiting really hard right now. And if you have any questions about it, that's our CEO, Jake's contact. He's also on this call. And I can put my email address in the chat as well. Thanks.
Thank you, Shrutika. That was really awesome. I mean, you covered all air, water, and ground in robotics, literally. So, and really nice to like know more about Autonodyne. I guess like it's really, really interesting what you guys do. So finally, like we are moving on to the next segment when we have a lot of questions for you guys. So thank you again, Shrutika. Thank you, James. And let's move on over to Dharini.
Thank you, Sanjaksha. So yeah, we have prepared some questions for the panel, and well, in order to understand how these interesting technologies work, the company's workflow, and what the future looks like, we encourage the audience to use the Q&A section to ask any questions you guys may have on the same topics, and the panel will answer in the end. All right, is everyone ready? So the first question is, well, for everyone, what applications of drones have the largest market share? Like, which are the most creative, the most useful, and the most challenging ones on the scale? Whoever wants to go first. Okay, James.
Okay, I'll go first. I think the largest market share is still probably the consumer segment. You know, essentially camera drones. Probably followed by more similar applications to that. So cinematography type applications. There are also those same types of hardware are used across real estate in particular. And you know, any application where like an aerial camera really would be used. I will say there's like an aerial camera. in terms of sort of advanced commercial applications, a lot of them are really still emerging. I think penetration is lower than I think most people in the industry would like, than we would like. A lot of discussion about drone use in agriculture, and that's really where we focused a lot of our effort. But it's tough putting advanced technology into those types of markets. It's a slow growth curve, and there's persistence. So I think there's a lot of potential there, and I think a lot of use, but it's not as easy to get into as we hope. We've really tried to streamline the customer experience as we can and make it easy for people to get into it. But there's still a lot of problems to solve. A lot of the regulations are still a little uncertain, and the technology isn't quite accessible enough for a lot of applications where you have a lot of other things to worry about. So, that's.
So just a little follow up on that as well. So
Sure.
what is the most challenging aspect of that, to getting more people interested or developing that technology?
I mean, personally, I think the biggest problems are not in technology. It's in the regulations. It's in training people how to use the technology, and making it be worth it for people to, take the time to learn and use the data, which is really where a lot of our focus has been over the last couple of years. You try to make the technology so smooth and easy to operate that it's kind of, they can do it by, without even thinking about it. The hard part is getting them to integrate that information into how they do things, which is just tough. You're training people to do things differently, which is always hard. And people have, whatever people do, whatever we all do, we have some kind of inertia in the way we do things. And now you're telling people you can do things a little differently and a little more efficiently by using these new tools, which is always a challenge. You gotta re-educate people essentially.
Makes sense.
It's really hard for humans to get used to robotics, I guess. That's one of the challenges.
Well, it's a change. It's definitely a change.
Does anybody have anything else to add? Shritika?
I mean, not really with the industry, what James said, videos are definitely the most common. I think some of the useful creative ones are, the agricultural uses are really cool and probably the lowest barrier to entry because it's usually kind of private land or something like that. But yeah.
Great. All right. So next thing I want to talk about is sensors. So how are sensors prioritized in drones? So I understand that each piece of hardware adds weight and it has to fly. So what is the selection process like, and how essentially does that differ from the sensors of, say, on a mobile robot or an AMR? Oh, okay. Whoever, James, go ahead.
Call me again. We are, well, with anything that's flying, and I think people that don't work in drone hardware maybe don't realize how critical weight is.
Yeah.
Is especially when you're doing full takeoff and landing applications. It's every gram, every 10 grams you add to the drone, it's another watt of power to maintain flight. And so weight is absolutely everything. The whole system is really designed around whatever the payload is. Ultimately, the system's goal is to fly that payload. The whole system is really built around it, and it has to be absolutely minimum weight. It's kind of the primary requirement. Everything else is, you have your functionality requirements, whatever you're trying to do, to shave every gram out of it. Just how we were able to get our drone to fly for 60 minutes is, counting grams, lightweight fasteners, everything. Nothing left on the table.
Actually, I should have asked this to the systems engineers. Go ahead.
Yeah.
Yeah.
Well, I was going to add on to that, so we don't make drones, but our software solution to that is kind of having the multi-vehicle control and being able to integrate with different sensors on each drone and know which drone has which sensors, because obviously that's really difficult to put multiple sensors on the same drone. That's
interesting. And what if one of the drone, like having a critical sensor maybe has a failure or something? Do you have like redundancies in the system as well? Because if you're having different sensors on different drones, and how do you manage that?
Yeah, so that would be kind of on the drone to tell us that there's some error going on. And then once we know that, then our autonomy would take care of it. We can't do this video recording behavior anymore because we don't have the sensor anymore.
That's a lot of trust on the drone to tell you, but I'm sure there's a lot of research going on in that department as well, like line robots and that kind of thing. All right, a follow-up on that. What kind of data do the drones collect, and how what sensors are being used for data collection versus autonomous operation, or both? I mean, do the sensors have like dual significance? Latimer.
I honestly, I am completely new to Green to James.
I actually don't want to call anyone out. If you have any inputs, please go ahead. Erica, maybe?
It's not an easy question to answer because it's very dependent on what the drone application is.
Maybe pick one. And
so, I mean, I guess if we're gonna look at drone delivery, let's say, you'd need a sensor, whether it's autonomous or not. You'd need a camera on it to do some kind of precision landing, if that's your goal. If you're trying to land on a mailbox with centimeter accuracy, you're going to need some kind of camera on there to do some kind of object recognition, so it can land super accurately, because GPS just can't get you there. And in that case, if it's an autonomous landing, you're not necessarily going to need to collect any data. If the pilot is interested in watching the landing to make sure it goes well, then we, like our company, would stream that video feed back to the common control station, so the pilot can be like using the remote control and watching the video feed, and be able to abort at any time that it needs to. But yeah, I mean, cameras can be used for data collection just as easily, just with taking snapshots or recording bits of information. The tricky part is how much memory do you have to save it all? Because video takes a lot of memory. So you need to be very specific on when you are recording and for how long.
That's now you give me a I can't like not ask this question. So how do you manage like memory? Do you stream everything, or do you have like the support customer support, like select what they want to view or that kind of thing? Or what does your framework look like in that case?
So we have the ability to stream any camera info back to the user. And I think Shrutika could answer this better, but I think it's kind of a default at this point. And if the user doesn't want to see it, then we have the ability to kind of reconfigure that. But streaming data is nice because you're not saving any info. Yeah, so if you want to start recording stuff so that you can play it back afterwards, then it's a little more finicky, and you kind of have to do a lot of research and development to figure out what your limitations are with that.
Makes sense. So since we are on drone delivery, how does your drone deal with variable size and weight of the payload in this application, or do you only use optimize, like all the time you make sure that it is in a certain range? How does that work?
Yeah, so a lot of that is handled with the drone's flight controller, which is not something that Autonodyne tries to play with. We try to stay away from that as much as possible, because we don't want to have to manipulate the vehicle itself. So there's definitely a range of size and weight based on how your flight controller is configured and the size of the vehicle frame itself. You know, you can't have a 50-pound package on a little 5-pound drone. It's not going to work out. So yeah, it's very much on the flight controller side, and there are variables that can be configured on the flight controller generally. So we use PX4, which I think is what GreenSight does as well, and they have a great user interface that you can change all those values in. You just have to be aware that if you're putting a heavier package on the vehicle, your flight time is going to drastically decrease.
So now you guys have like a wide range of customers. So you mentioned that this application is something that needs a flight controller to change. So do you have a separate set of software for each application, each customer, or do you have something modular and you just have to tune some parameters to make sure it works?
I can take this, Shrutika, if you don't. Cool. Yeah, so for the most part, our software is universal, with the intent that, as Shrutika mentioned before, you know, we are a remote that will work on any kind of vehicle you want to connect to. But obviously, there's many different kinds of vehicles out there and they require different information. So the core of our product remains the same across the board. Most of our modifications are done when it comes to connecting to new vehicles and integrating to different sensors, integrating to different radios. We try to remain essentially a black box and have like many different ports that you just connect the right ports to the right places based on what vehicle it is on the software side.
That's a good analogy. Thanks.
Yeah, I can add on to answer Zoe's question in the chat as well. She asked, are there any standards or common formats for data or controls that you use, or do you typically have to customize a lot for each individual vehicle? So like Erica said, we have definitely have a black box that we add on different things for different standards, but there are a couple of like common standards. Like one of the major standards to communicate with drones is called Mavlink. And there's different ones for like DoD work. So there's a couple of common ones, but we definitely customize a little bit based on the vehicles.
Thank you, Shrutika. So yeah, this is something that I wanted to know for both the companies about the testing process. Can you describe how do you do that, and like do you have indoor and outdoor testing environments? James, if you want to start.
Sure. I mean, we do a lot of testing, and it varies depending on kind of what we're doing, whether it's kind of new systems, new prototypes, new hardware, versus stuff that we've built a lot of and we're just manufacturing more of. We tend to have a suite of laboratory tests that we do, and we actually have a whole process where we actually have a tracking system where the aircraft are in sort of a state tracker, and they go through a whole initially tested in the labs. There's some like functionality and setup tests that happen. And then they actually go into a queue where they get sent out to a field for flight testing out in the real world. And every single drone that we manufacture, actually any drone that gets serviced at all, gets flight tested, put through the exact same cycle that it goes through at a customer location before it goes to a customer. New aircraft go through that process twice. They actually go into our truck, they get driven to the field, flown, data gets processed, and that happens twice for a new drone, and it happens once whenever a drone is serviced before it goes to a customer, which is all part of our kind of QA process to ensure that we don't get any faulty drones being sent to customers. And that's actually one of the things we've kind of developed over the course of many years is kind of what things need to be tested, where your problem areas are, what things need to get shaken out. And it's been, it's a tough process to figure all that out in a way that catches all potential problems.
Thank you, James. Shrutika, do you have anything to add?
Yeah, so for us, testing usually starts with sim testing in the lab because we have so many multiple types of vehicles. So we have a sim environment that allows us to try out new behaviors without risking any equipment or people's safety. And then we move on to hardware in the loop and test the software on the physical drone, but still in the lab. So like different parts of it. So that might mean making sure a sensor is integrated properly, it's sending proper data, or the radios are connected, things like that. And then we start flight testing outdoors. So we have a test pilot, and sometimes systems and software engineers will go out there to make quick bug fixes in the field as well. We test in all kinds of weather. We've tested in the snow in the middle of summer. I think I mentioned earlier, we test at the drone cage at Costas Research Institute in Burlington, Mass, pretty often.
We also share a testing site with GreenSight as well. They've been
Oh, that's
gracious
nice.
enough to loan the space to us.
Yeah, we
Good
have a
collaboration.
farm. We have a farm that we rent, who have facilities there. We have a storage facility, a little office and generator. And it's a nice place for us to go where it's away from any airports and other concerns.
Sounds
So-
like a good field trip.
Yeah, well, finding a good, reliable, and safe place to test these things is in itself sometimes a challenge.
So, like finding is a challenge as well, but there must be like weather challenges as well. So, how do you deal with that? I mean, what weather conditions are your drones sustainable in? What happens in case of failures?
Well, we watch the forecast a lot, and we don't really fly in bad weather. Mostly because the imagery that comes back from the aircraft is not good if the weather's bad, so it's not really worth flying. If we were delivering packages or doing something else where we had kind of a mission other than producing imagery, might be different. But generally, we don't fly above maybe 15 or 20 mile an hour winds. The aircraft have no problems with higher winds; they won't crash or anything, but the data will be impacted. And any kind of precipitation, we don't fly. You see all that in the, we've flown before, and there's like streaking rain or snow, and it just ruins the data. So it's not really worth flying. Although the aircraft are not really particularly impacted by it. But yeah, we tend to, you're kind of a slave to the forecast when you work in drones, unfortunately.
Yeah, I mean, I didn't realize that even the data would be quite useless, even if they can fly, if the rotors are that strong. But even then, like, we don't have that much hardware to
Yeah.
deal with
You just
that.
see,
Sense.
streaking rain down from
Yeah.
the sky. That's all you get.
True.
But it's just pretty impressive that they can fly in such environments. I mean, I've seen small drones just crash at the first sight of wind. So
Yeah.
it's pretty impressive.
I've flown in hail before that sprung up, was completely sunny when I took off, and then while the drone was in the air, storm blew in and started hailing really hard, which the drone did. The propellers were getting hit by hail, and it didn't crash.
Wow.
Pretty extreme weather change from takeoff to landing.
Interesting.
I just have a quick question following up for that. So is this specifically a hardware thing that you do for it to be like more sustainable? Like what kind of hardware information?
Yeah, we tend to make things as weatherproof as we can. We don't design anything to be kind of submersible. It's really not necessary, and it would just add weight to the system. But all of our PCBs are conformal coated, so they can withstand some moisture, and everything's designed to kind of keep just general water out of and moisture out. But things aren't designed to be completely waterproof. We don't need it. So you can stick one of our drones out in the rain; it'd be totally fine. If you submerged it in a lake, probably would not be fine. We actually did that a couple of weeks ago, which was unplanned.
You just put it in the water?
One of our customers, they have a hand controller for safety. They decided to land it in the lake. It was, yeah, we had to do some additional training with them later. But these are the risks. Unfortunately, flying vehicles are tough. Anything goes wrong, it's got to have everything on point. All the hardware has to work. All the operations have to be tight. There's not a lot of room for failure. A propeller goes out or something, and it won't stay in the air.
Every failure is a literal crash.
Pretty much, yeah. Got to have a very reliable system.
That was a cool story. So next I want to talk about mapping. How is mapping using drones different from AMRs per se? And is it better in terms of data collection quantity and or quality than AMRs? Yeah, Shrutika? I think someone else asked this in the chat as well, but yeah. Shrutika, if you want to go first.
Sorry, can you repeat the question?
I was asking about the how is mapping using drones different from mapping using mobile robots or industrial AMRs? Mapping of the environment is done on drones.
We use databases right now to map.
Okay.
Yeah. We're looking at using ingesting different sensor data. So part of we're working on the wildfire fighting scenario, and that's ingesting sensor data to be able to add on layering to our mapping. So kind of what I was talking about with knowing the weather, where the fire perimeter is, stuff like that. But right now we mainly use databases.
So the environment is mapped before you move in. So for every customer, you might be doing it again, right? For every customer, you'll be doing it separately.
So most of our stuff is done outside. So a lot of these databases we're taking are just maps, satellite maps that you can get off of Google or so and it'll have terrain data in there as well. We haven't done integration with vehicles that can do indoor mapping of unknown spaces. We haven't done much of that. So that might be more of a question for GreenSight. But yeah, off the top of my head, there are some very cool applications that you can do with mapping with aerial vehicles. Just if you have a lot of them, there's some really cool research papers out there about stitching individual maps together from a swarm of drones to create a larger map to get a true common operating picture of what's going on. That has applications in search and rescue environments, wildfire environments, things like that. It would probably be much quicker than any kind of vehicle that is trekking along on the ground, just because drones are really fast and really good at being mobile.
Thank you for clarifying that. Sorry, my question was a little confusing, but yeah, it definitely makes sense. And so you mentioned that you use a swarm of drones to you can use to map the environment. Is it so they would be definitely looking at different spaces, and then you'll be stitching them together, or do the drones communicate with themselves as well to know what they are doing or which area they are looking at?
Yeah, so that gets into some really fascinating research going on that is truly research at this point. I haven't seen many true applications of this, but that's getting into the difference between a group of vehicles that are considered a flock and a group of vehicles that are considered a swarm. And the difference between those two is a flock of drones will be gathering their own information completely unaware of each other. And they're going to send that data back to some operator or some main computer that is housing all of the information at once in a centralized location. A swarm of drones, they now can communicate to each other. They are aware of each other. They are passing information back and forth between each other. And that is some pretty intense stuff and really cool applications, but the technology isn't quite there yet. We are working on it. We're having a lot of fun working on it, but yeah, still something that's sort of a dream for the industry.
I kind of worked a little bit on coordination. That's why I got sidetracked with this, but it's really interesting.
But it's
Thank
really
you
cool
for
as
answering that.
well.
Yeah.
Yeah, like swarm robotics is really fun.
So
I hope we can have some swarm robotics events in future, and we can call you again for that.
yeah. So yeah, I wanted to talk about if you're looking for more engineers as well. So what additional skills does a person require to work in the drone industry, and what background in general do they need? Latimer.
Sure, I can give my opinion at least. I won't speak for James or Joel, but as far as I think, if you want to be hands-on and technically focused, working with the software or the hardware, probably having a degree or degrees in mechanical or electrical engineering or computer science or even robotics would be helpful. It can help get your foot in the door, and you'll kind of have that solid knowledge base from which to build upon. But is having a certain degree necessary in general, and will it help you move up the career ladder? In my personal opinion, at least, I think no. I think the kind of intangibles, if you will, are a bit more important than any specific degree you may have. Things like willingness to work hard, ask questions, ask for help, be kind and polite and respectful, but most importantly, just be curious and have a passion for learning, because there's so much to learn in this field, and it's constantly evolving.
That's
Totally
cool
agree.
answer. Yeah.
Yeah, I totally agree with you, Latimer. Like asking questions specifically is so important. You'll never learn and move ahead if you don't ask questions. So thank you for that.
Sure.
Does anybody have anything to add?
I would just add to that, in addition to insatiable curiosity, being flexible is really important too. Anybody that has worked with robots knows that they are finicky beasts, and they like to break given any opportunity to break. So there are often times where our software department will come up with an excellent solution to a problem, but it only works on the computer. As soon as you put it on a drone, it doesn't work for whatever reason. Hardware constraints, the sensors aren't giving you data as often as you thought they were going to, variety of issues. So you have to be able to take that awesome solution that you come up with and then be able to adapt it to new environments. And that can be very tricky, because I think engineers like to give optimal solutions. And the key is figuring out what is the optimal solution for the entire system, not just this one small piece of the system.
That actually brings me to my next question about systems engineering. Even you work for do you have a computer science background, and even Latimer worked in software before. So how do you how do you feel about working in systems, and what is different? What exactly does the role mean, and what it signifies?
Oh, I can try and tackle that first, at least. But I think that's a great question, because in my experience, at least, I've found a lot of people think that systems engineers don't really do much, or they wonder what we do. And a lot of other people think systems engineering is not necessary, but I can say that is not true, neither of those things. If you kind of think of software and electrical and mechanical engineering and other engineering disciplines as kind of separate points, I kind of think systems engineering is kind of the glue that connects those points. That's how I like to think of it, at least. How do the software people know what to code and what to program? How do the hardware people know what to design and build? And after everything is coded and built, then what happens then? Those are the kinds of questions where systems engineering comes in. And we'll take what a customer wants and turn those into formal design or requirements, and then make designs from there for the different engineering disciplines, move into implementation, make all the parts, all the engineering disciplines will make the parts. Then the parts have to be combined, and there's plenty of testing to be done. And after that, verification, validation, making sure what was built meets those requirements we came up with way back when. So there's really a lot to it. And personally, that's one of the reasons I enjoy it, because it's such a wide-ranging discipline. And I think that systems engineering is also a necessary part of platforms, because a drone is basically a collection of parts, a system of parts. And drones, as James was saying, and our other panelists have been saying, they're used for a myriad of different reasons. So they have all kinds of requirements. So to kind of help streamline the development environment and help connect all those parts, I think systems engineering is very important in the industry.
As a plug for Autonodyne, I think, since we are recruiting right now, we really look for systems and software engineers. So I think like the title systems engineer encompasses a lot of different things, like Latimer said. But I think to a lot of people, it's like mostly managing the project and its life cycle and keeping that on track. But for our company at Autonodyne, at least for me as a systems engineer, I'm kind of the interface between the hardware and the software, since we're mainly a software company. So we integrate, like I mentioned before, we integrate with a lot of different vehicles and radios and things like that. So as a systems engineer, I can understand the hardware enough to like relay those details to the software engineers. And in some cases, even do that middle layer myself and do that integration myself, or at least like begin to work on it. So I think in some ways it is kind of like ends up being managing the project, because I know what is going on both sides, but day to day, I get to use kind of my software and hardware skills, which is really cool.
Yeah, I really like Latimer's concept of us being the glue. We really do try to see the big picture of what is the system as a whole, and make sure that all the moving parts are talking to each other well. If we get to be part of that, like Shrutika was saying, if we get to do some of the integration, if we get to do some of the software development, that can be a part of it. And I personally love that aspect. But because we see the big picture, we're also put in a role of kind of managing the projects as well and keeping them on track.
Yeah, I totally agree. It kind of binds everything all together and make sure that everything is working fine. Thank you, Vladimir, Shrutika, and Erika, for showing us another way how to get into robotics and in the drone industry as well. So yeah, just a last question from me. What future do you envision in drone technology? Okay, James.
Well, the sky's the limit. There's so many different applications, which I think is maybe one of the big challenges. I mean, it's people are still trying to figure out where the real killer apps are in terms of business applications. The costs of all the logistics and deployment are still emerging, and there's still a long way to go in terms of the regulations in particular. I think the technology is ahead of the regulations right now. The idea that you could have fully autonomous drones, like taking off from docking stations and doing cool stuff, maybe delivering packages or surveying farms with no human really in the loop, there is I think technically very achievable. From a regulatory standpoint, there's still a lot more to do there. And the regulations and the technology, there's a lot of interplay there. The systems have to be high reliability, they have to be assured, high assurance, and well, there's a lot to be done there. And I think all these things kind of move lockstep. So it's and are changing rapidly, I will say. Even despite, I guess, things, there being a lot to do, there's still new things happening every day, which is definitely makes it an exciting place to work.
Well, we'll be sure to follow both GreenSight and Autonodyne to know what's next. So yeah. Thank you. Do anybody else has anything to add? Kritika?
One of the fun, I guess, long-term future of drones is the urban air mobility stuff. So all the Uber Elevates of the world is really interesting. And it's kind of, I mean, I did a dual major in public policy, so it was engineering and public policy. So I kind of thought about that stuff a lot and worked on, like, one of my capstone projects was on that. And just, again, it's definitely like the regulatory stuff that's the holdup right now. But I mean, there's people working on it, and it's fun to think about, even while we're working on these small scale drones, how eventually it could scale to that level.
Sounds good. Thank you so much. Thank you so much, everyone. So this is the end of my discussion. And yeah, we just have one more live question from the audience. Sanjuksha, do you want to take that?
Yeah. So this is a very interesting question, which even I wonder. So do you have any like third-party simulators, or all of your simulators are written like in-house?
I guess this was for Autonodyne.
Yeah, you said you also like test in simulations, right?
Yeah.
Yeah, so the main simulator that we use right now is called Gazebo, which is used for a lot of robotics applications. And there are different models in there for different vehicle frames, and we can connect to that with our app, and we'll just run some radios in our office, and we can be directly messing with the app and making sure that things are working properly and attempting to break things. And we'll see the drone flying in the air in the Gazebo simulation. That's how we started with multi-vehicle behaviors as well, when we were starting to branch into that, because that can be a huge safety issue. You know, you have one flight pilot, and you kind of need to know for sure that at least one of the drones is not going to fall out of the sky if you've got 5 in the air. You know, there's only so much a human pilot can do. So that was definitely helpful in kind of assuring that as we were starting to do multi-vehicle behaviors, things were going as planned.
So much. I mean, I love Gazebo myself. I try stuff in it all the time, and yeah, I think it would work pretty good for drones as well. So
yeah, we are ending. We are nearing the end of our session, and thank you so much for staying a little late for answering the question from the audience as well. And thank you, Shrutika, for quickly replying to them in the chat. So yeah, once again, thank you all for coming tonight, and special thanks to Joel and Steve for making this happen. We really learned a lot from how things work and what you guys do. And I hope you all had a good time as well. And be sure for the audience, be sure to check our upcoming events. We have a couple. So yeah, thank you. Sanjuksha, do you want to add anything?
yeah, I just want to say thank you for myself as well, everyone, for joining us today. And please, for all our attendees, please make sure that you make the most use of all the opportunities Autonodyne and GreenSight has to offer. So please do not hesitate to contact any one of them. Like, they have all that information in the chat section. So please make the most of it, and hope to see you guys again sometime.
Thank you, guys.
All right, thank you.
A lot of fun.
Thank you.
Thank you.
Thank you.
Bye.